Hello guys, and welcome to another video. So in this video we'll be looking at the topic of Doppler effect. Okay, and Doppler effect, guys, is basically a type of concept that we'll be looking in wave physics, where we talk about the change in frequency or the change in pitch of a wave, and this will be in relation to what? To the observer who is moving relative to the wave source. Okay, those are the things that we'll be looking at. And then here, this is the definition of Doppler effect. So the definition of Doppler effect is that it is the change in frequency or pitch of the sound detected by the listener because the sound source and the listener have different velocities relative to the medium of sound propagation. Okay, so that's how we define Doppler effect. And before we get into other parts of this topic, I want us to look at certain things which we learned about in grade 10. Firstly, the relationship between frequency and wavelength, because we will be dealing with this a lot. So the relationship between frequency and wavelength, guys, is inversely proportional. And that means if I'm going to have a high amount of frequency, then I will have a short wavelength. And if I'm going to have a large wavelength, that means I'm going to have a high amount of frequency. Okay, so those are the things that we have to understand. Another relationship I want us to look at is that of frequency and pitch. So the relationship between frequency and pitch is going to be directly proportional. This means that if I'm going to have a high amount of frequency, then I will also have a high pitch. Another fundamental thing I want us to look at is the relationship now between pitch and loudness. Pitch and loudness. So here again, the relationship is going to be directly proportional. That means the higher the pitch I have, then the louder my sound is going to be. All right. So frequency influences pitch and pitch influences loudness. All right. So those are the things that we will need to know, and these are things that we learned about in grade 10. Okay, when we were doing waves. Okay, transverse waves, longitudinal waves, yeah, those waves basically. So that's what I need us to look at. And now we get into the grade 12 content. So we've gone through the definition of what is Doppler effect, and now we are going to look at how Doppler effect actually works. Well, here we have a situation firstly whereby the source is moving toward a listener. What type of source are we talking about? Well, normally we'll be talking about an ambulance, for instance, and we know that when an ambulance is probably maybe in an emergency situation whereby they are transporting a patient to the hospital, it will be having a siren. Or we can have a source that is a police car. So let's say the police are running to a certain crime scene and they want to get there as fast as they possibly can. They will obviously be sounding their siren just to get the other cars out of the way. And that's how you'll know that, oh, a police car or an ambulance is probably on the way, okay, or approaching. So that is going to be the source of or rather the source that produces this sound, and it will be moving toward a listener. So here we are going to have sound waves which are compressed, and this means that the wavelengths will decrease, which will result in a higher frequency and a higher pitch. Remember what I said initially when I introduced the video? I said when it comes to this topic, we are going to be looking at the relationship between frequency and wavelength. So this means that, guys, if we have our source of sound approaching our listener, the listener will hear a very loud sound. And why is it that the listener will hear a loud sound? It's because that listener or rather that the source will be having compressed waves, okay, compressed sound waves, that is, and those compressed sound waves will mean that the wavelengths thereof are actually short. Thus we will have that decrease, and because the wavelength will be short, that means we will be having a short wavelength, then the frequency will have to be higher, okay, and if the frequency is higher, then it means we will also end up having a higher pitch, which will have us here a loud sound coming from the siren. And then we will have another situation whereby now the source moves past the listener and away. So the source will be now moving away from the listener. In that regard, our sound waves are going to be stretched. And if the sound waves are being stretched, what does that mean? The sound waves being stretched means that we now have wavelengths that have increased. So the situation will be the opposite of this. And if the wavelengths have increased, we should then have a low frequency and a low pitch. Thus, that inversely proportional relationship which we talked about. Okay, so those are the things that we need to know when it comes to this topic. All right, now let's look at the applications of this Doppler effect. This Doppler effect is something that is applied in the real world. Okay, so here the Doppler effect is not just about us hearing those siren sounds from our sound sources, but it also works in the clinical applications of technology and medicine. Firstly, in terms of medicine, it will work in the form of ultrasound, and here it will be used to measure the rate of blood flow in veins and arteries. An ultrasound wave is reflected off moving blood cells. The frequency shift tells us, or rather, well, not us because we are not doctors, but it tells doctors how fast the blood is moving within the veins. Okay, then it will work in terms of flow meters. Here it will be used to measure the speed of liquids in pipes. It will also work as a radar in terms of policing. Here it will be used to measure the speed of a motor vehicle by bouncing radio waves off the moving car. Okay, so this is what the traffic officers basically get their information from in terms of speeding cars. Okay, Doppler effect has a part in that. And then it will work under meteorology, and here it will be tracking the velocity of storm clouds and precipitation. So Doppler effect, guys, works under those things. Okay, now let's talk about how to do calculations in terms of the Doppler effect. So the Doppler effect will use this formula here. Okay, this formula is FL is equal to V plus or minus VL divided by V plus or minus VS multiplied by Fs, whereby this FL is our frequency of the listener. It means it's what the listener is hearing. Okay, and then this V will be our speed of sound. VL will be the velocity of the listener or the speed of the listener. Vs will be the velocity or speed of the source, and Fs will be the frequency of the source. Okay, these are our variables. So here they are. We firstly have FL. This is the frequency detected by the listener, and then it is measured in hertz. Fs is the frequency that is coming from the source, also measured in hertz. And then V will be the speed of sound, which is most of the time 340 meters per second. It's measured in meters per second. And then we have VL. VL will be our velocity of the listener. Okay, and last but not least, we have Vs, and Vs will be the velocity of the source, also measured in meters per second. Let's talk about a crucial thing here. You see here it's denoted as the golden rule. Very crucial this thing of the sign conversions. That's what I want us to talk about, because if we look at our formula, guys, you'll realize that our formula is FL is equal to V plus or minus VL divided by V plus or minus Vs multiplied by Fs. So one should obviously wonder, but if I am having two signs, how am I gonna do my calculations? Do I put both the signs on the calculator? What exactly goes on in terms of using this formula? And the answer is, well, you are not gonna put two signs, but you are gonna have to choose one. Okay, but this is how you choose your signs. I usually make reference to my velocity of a listener. I also make reference to the moving and moving away of my source. That's how I choose my signs. So this is how we choose our signs, guys. Let's say we have the source approaching. Let me write here, source approaching. So if we have the source approaching, this means that when we choose our signs, we will then say that the velocity of the listener is positive. If our source is approaching, the velocity of the listener has to be positive. Do you hear me? And the velocity of the source will be the opposite of what the velocity of the listener is in terms of the sign when the source is approaching. And what that means is that if the source is approaching, the velocity of the listener is positive. What is the opposite of positive? It's negative, and that means the velocity of the source will be negative. Source approaching, velocity of the listener is positive. Velocity of the source is the opposite of positive, which is negative. Okay, then we are going to have another situation, a situation whereby our source is moving away. Okay, and this works for both the source approaching and the listener approaching. But for now, like I said, I use the source as my reference. So another scenario is when we have the source is moving away. Let's say source is moving away. So if the source is moving away, then it means the velocity of the listener is going to be negative. And if the velocity of the listener is negative, then the velocity of the source will be the opposite of that negative, which is positive. So the sign of the velocity, of the listener, the velocity of the listener is the one that helps us to know the sign of the velocity of the source. If the velocity of the listener is positive, the velocity of the source is negative. If the velocity of the listener is negative, the velocity of the source is positive, depending on whether we are approaching or moving away. So away means the velocity of the listener is negative and the velocity of the source will be positive. I hope that is clear, guys. So here we have that thing of our golden rule in terms of signs convention. And here we are looking at towards. And we know that if we are moving towards, we should be increasing in frequency and decreasing in wavelength. And we see that the sign of the numerator, which is the sign for the velocity of the listener, is, positive. And the sign of the denominator, which is that of the source, is negative. So they are opposites of each other. And if we have a situation whereby the source or listener is moving away, then that means we are going to have our frequency decreasing. And if our frequency decreases, that means our wavelength will be increasing. And we see that the velocity of the listener, which is the numerator, will be negative, while the velocity of the source, which is the denominator, will be positive. Okay, so let's make sure that we understand that. And then another important note is that in grade 12, the type of questions we solve will have either the source or the listener being stationary. So one of those two things has to be stationary. Okay, they will not be both moving in terms of the grade 12 syllabus. All right, let's now move on to another important aspect. Here we are now going to talk about the Doppler effect in terms of light and astronomy. Okay, so here when we talk of the Doppler effect, you will learn that the Doppler effect also applies in terms of electromagnetic waves, particularly what? Light, which allows us to study the movement of stars and galaxies. So the Doppler effect concept is also about us knowing or learning about the movement of stars and galaxies. Okay, and that movement, guys, is based on two shifts. We firstly have the red shift and we have the blue shift. For us to explain this, we are going to look at our light spectrum. Okay, so the type of light spectrum we have is called Roig beef. Yeah, it's this Roig beef. Okay, these are the types of lights we have. We have red, orange, yellow, green, blue. This will be indigo and this will be violet. So this is our color spectrum, if you will. And in terms of this color spectrum, this is what we need to know, that when we are moving from the red side going to the violet side, then we will be increasing in frequency. Okay, let me use a different color there. So when we are moving from the red to the violet, we'll be increasing in frequency. Okay, increase in frequency. And when we are moving from violet to red, we will be increasing in wavelength. And we remember that I'm just gonna show an arrow and lambda. So when we are moving from red to violet, we are increasing in frequency, and when we are moving from violet to red, it means we are decreasing, we are increasing in frequency. If we remember, guys, the relationship between frequency and wavelength, we said that they are inversely proportional. So it means that if we are moving from red to violet, the frequency is increasing, and that means the wavelength should be decreasing. Okay, so if we ask ourselves, from these colors, which one has the highest frequency? Violet will have the highest frequency, and if it has the highest frequency, that means it will have the lowest wavelength. But I want us to mainly focus on color red and color blue, because this is what we need to basically understand this red shift and blue shift. So here, guys, if I'm moving from red to blue, I'm increasing in frequency, right? And we know that an increase in frequency, or rather, let's start with red, since red shift is the first one. Let's start with red. So if we look at red, it means that we are moving from blue going to red. And if I'm moving from blue going to red, what does that mean? It means that I am decreasing in frequency, right? I am decreasing in frequency, and if I am decreasing in frequency, that means I am increasing in wavelength. And what did we say about a decrease in frequency? We said that a decrease in frequency means that something is moving away, right? So if we talk of this redshift, then we will make reference to a star to say, where is our star or galaxy going? Is it moving towards the Earth, or is it moving away from the Earth? So since we are seeing us moving from blue to red means we are decreasing in frequency. It means when we talk of the redshift, we mean that our star or galaxy is actually moving away from the Earth. Okay, it's moving away from the Earth based on this thing here of our color spectrum, and this means that the light waves will be stretched, and that means the wavelength will be longer, and this means that we will be moving towards the red end of the spectrum. Remember, this is the color spectrum we are making reference to say that we are moving from blue to red, or we are moving towards red. Moving towards red is us decreasing in frequency and increasing in wavelength, and that means us decreasing in frequency means that we're actually moving away. But in terms of the shift, we are saying that the stars or the galaxy is moving away from the Earth. So that's what the observer will see. If we are observing that shift, it means we will see red, and that red means that we will actually be having our stars or the galaxy moving away from the Earth. Thus we say we have a red shift. Then if we talk of the blue shift, that's us moving from the red color spectrum going to the blue color spectrum. And if we look at how our frequency is being influenced, you will realize that frequency is actually increasing, and if frequency is increasing, we will be decreasing in wavelength. And what does that mean? An increase in frequency means that the approach is what is happening, we are moving towards. So in terms of this blue shift, or making reference to the stars, we will talk of the stars or the galaxy to say, because the frequency is increasing, that means we are actually moving towards the Earth, or rather the star. Yes, the star or the galaxy is moving towards the Earth, and this means that our light will be having what? It will be having compressed or shorter wavelengths, and that means frequency will increase, which means that we are moving to the blue end of the spectrum. Okay, and us moving to the blue end of the spectrum means we are experiencing what? We are experiencing a blue shift. Okay, so that's what the Doppler effect is in terms of light and astronomy. I hope you understand that part, guys. And now we move on to the last part of these notes, or this topic, the expanding universe. What does this mean? So according to what scientists uncovered, the observations will show that light from distant galaxies is redshifted. And if we see this redshift, it means that the galaxies, if not all, so it means that almost all the galaxies, if not all, are actually moving away from us. Because remember, we said if we talk of a redshift, it means that the stars or the galaxies are moving away, right? So it means that if we are having an observation whereby we are seeing the distant galaxies in terms of the redshift, that means the galaxies are actually moving away from us. And this led to scientists believing that if we are having this type of experience, then the universe is expanding. So us seeing the galaxies move away from us, or experiencing or observing the redshift, means that the universe is actually expanding. Okay, and that is it in terms of the theory part of the Doppler effect. And then on the next video that I'll be uploading, will be some past paper exam questions. I hope, guys, you will enjoy watching this video. Oh no, I hope you enjoyed watching this video, since this is the end. And please, guys, don't be afraid to share with your friends who are doing physical sciences in terms of them understanding the Doppler effect concept. Also, guys, be kind in terms of liking this video and also subscribing to the channel. I'll see you on the next one, and goodbye. Happy learning.